Hi guys, welcome to this page of the notes. Now what we're going to do, just to make sure that you don't forget how these work, I actually threw in a 2x2 matrix for you here. Again, remember, you know that I want you to find a determinant because I've got those bars on either side of it. So let's go ahead and calculate this. Again, these are the easy ones. We love it when we get these 2x2 matrices. I'm going to take the major diagonal, 1 times 4, which is 4. I'm going to subtract from it the minor diagonal, which is a negative 1 times 3. Comes out to be a minus 3. Watch your signs. Add the opposite, and I get 7. Okay, great. Scroll on down to the next one here. And we're back to, okay, here we go. So now we got ourselves another 3x3 matrix. I'm liking the way this one looks so far. I'm seeing a lot of zeros. We love zeros. Zeros are going to make us do a little happy dance anytime we see zeros. It's good news for us. Makes the calculations a lot faster. So rewrite the first 2 columns outside of my bars. And now we go ahead and start calculating my products. My first diagonal, 0 times 3 times 5. Love it, that's a 0. I'm going to have my next diagonal also has a 0 in it. So there's that one. And then, oh, no, definitely going to get a number here. How about a positive 4? So that means my bottom number comes out to be 4. Okay, let's go the other way. I got a negative 1 times 3 times 1 should be a minus 3. Looks like the next ones are all going to be zeros, right? That's 0. That's going to be 0. So I got 0 plus 0. And we're going to wind up then with just our minus 3. Go ahead and do bottom minus top. Be careful. Watch your signs. And once again, it looks like I get a 7. Now, here's what's interesting. Let's talk about this for a second. I got a 7 up here on this one. I got a 7 down here on this one, and you're probably wondering what the heck is going on here. How can a 2x2 matrix and a 3x3 matrix both have the exact same determinant? A determinant is just going to be a constant, a number that we will associate with a particular square matrix, all right? They certainly can have the exact same value even though they're not the same matrix. And again, the reason we're finding these determinants is because we're going to need them when we learn Cramer's rule. Cramer's rule is going to utilize these determinants, these constants, all right, that represent the determinant of a matrix. So please don't let it throw you off that we wound up with the exact same determinant for both of these guys, even though they're different matrices. That is okay. All this is just a number representing, it'll be a constant, it'll be a number representing the determinant for that particular matrix. All right, so head on over to the next page. I got a few more here. Let's give these ones a shot. Make sure we've really got this finding 3x3 determinants down. Again, we're going to rewrite the first 2 columns. A lot less zeros here, so this one's going to probably be a little trickier. I don't know. We'll see. Once again, we're going to do those major diagonals. So here we go. 2 times 4 times 1, I get an 8. Ooh, goody. There's a 0 in this one, so that's going to be easy. Oh, and I'm going to wind up, okay, so not terrible. Got a negative 1 times an 8, so I wind up with minus 8. That is interesting. Look at that. We wind up with a bottom number down here of 0. This one's working out better than I thought it was going to. Okay, here we go. Minor diagonals going up. That's going to be a 0. Really like those ones. 8 times 6 times 2, I get 96. That might be the biggest number we've seen so far. 3 times a negative 1 times 3, that's going to be a minus 3, which is going to leave me with a positive 93. Positive 93. All right, it's going to be bottom minus top. 0 minus 93. And the determinant of this is going to be minus 93. Great work, guys. One more for you here on this page before we go ahead and try something different. Let's give this one a shot. Oh, I'm liking the look of this one. Look at all those zeros. We like zeros. 0, 4, 0, 2, 3, 6. Here we go. All right, that's going to wind up being a 9. That's going to give me 0. And 3 times 4 times 6 is 72. So I wind up with 72 plus 9. Sorry. I said it. Look at all those zeros. This is going to be a good one. And then I ignored my zero. 0 times 3 is going to be 0. Sorry. We wind up with 72 as my bottom number. Okay. Let's go the other way. I won't forget it this time. We got that 0 in there, so we're going to wind up with a 0. We got more zeros. Love those zeros. And then my last one, 3 times 4 times 2 should be 24. All right. We're going to do bottom minus top. So we're going to wind up with 72 minus 24. When I do 72 minus 24, I get 48. Alright guys, hopefully at this point you feel really comfortable with doing both 2x2 and 3x3 square matrices and finding the determinants of those matrices. We're real quick going to do something here on the next page of the notes with finding the area of a triangle. Just going to pull out a little geometry on you, but geometry you've not seen before. And then after that, we'll jump into Cramer's rule. Really excited about showing you how to find the area of a triangle using determinants. So head on over to the next page of the notes, and I'll meet you guys there.